Now in this session we are going to see the carbon dioxide laser construction and working as a part of module 4 quantum mechanics and lasers. Now we go with the carbon dioxide laser. Carbon dioxide laser was developed by C.K.N. Patel in the year 1963. What is a carbon dioxide laser? Carbon dioxide laser consists of two oxygen atoms and one carbon atom. You can see here carbon dioxide laser consists of two oxygen atoms and one carbon atom. See, there are three different modes of vibrations given as follows. What are the three different modes? Now we see what is a symmetric stretching mode. In a symmetric stretching mode, as we have discussed here, CO2 molecule is having a center carbon atom and two sides you have an oxygen atom. All the three atoms are lying along a line called as a molecular axis. In a symmetric stretching mode, what is happening here is carbon atom is fixed and the two oxygen atoms either move away from the carbon atoms or move towards the carbon atoms. You can see both oxygen atoms are moving together moving towards the carbon atom or moving away from the carbon atom. That means here carbon atom is stationary in the symmetric stretching mode and two oxygen atoms are either moving towards the carbon atom or moving away from the carbon atom, and it is along the molecular axis. The axis which joins all the three atoms is called as a molecular axis. Here along the molecular axis oxygen atoms are moving towards and away from the carbon atom. This is called as a symmetric stretching mode. Next is asymmetric stretching mode. Here in an asymmetric stretching mode, you can see that here carbon atom is moving in one direction, that is negative x-axis, and oxygen atoms are moving in the positive x direction. So here all the three atoms, that is carbon and two oxygen atoms, are moving along the molecular axis only, where the carbon atom and oxygen atoms are moving in opposite direction. That means both the oxygen atoms are moving in one direction and the carbon atom is moving in the opposite direction, but the motion is along the molecular axis. This is called as an asymmetric stretching mode. Next is a bending mode. What is a bending mode? Here all the three atoms oscillates. Here you can see this bending mode, all the three atoms are getting oscillated, but they are perpendicular to the molecular axis. This carbon atom is moving in a positive y direction and both the oxygen atoms are moving in the same direction, but it is moving along the negative y direction. And you can observe here that it is the carbon atoms and the oxygen atoms are moving perpendicular to the molecular axis. So this is called as a bending mode. So we have seen three types of modes: symmetric stretching mode, asymmetric stretching mode and the bending mode. Now we go with the construction of a CO2 laser. Now you can see here in the diagram, here it consists of CO2 laser consists of a discharge tube of diameter 2.5 centimeters and the length of about 5 meters, and the tube is water cooled Now tube is filled with mixture of CO2 gas, nitrogen gas and helium gas. Here you can see here the tube is filled with, the discharge tube is filled with carbon dioxide gas, nitrogen gas and the helium gases in the ratio of 1:2:3. Here the discharge tube is having a mixture of carbon dioxide, nitrogen and helium in the ratio of 1:2:3. And you can see here two electrodes are placed to achieve the pumping. It is given by electrical pumping, high tension it is given. So it is given, the pumping is being done by the electrical, it is a high tension voltage is being given. Now you can see here the Brewster's windows. You can see here this is a Brewster's window and this is another Brewster's windows. Brewster's windows are sealed at both the ends to give the polarized outputs. Brewster's windows gives the polarized output. Here you can see the resonant cavity as discussed before. It is a fully reflecting mirror and this is a partially reflecting mirror, which constitutes a resonant cavities, where one is fully reflecting and the other one is partially reflecting, and laser light is being exited in this direction. So from the partially reflecting mirror laser light is being given out. So here there is 100% reflectivity from the fully silvered surface, polarized light and partially reflecting mirror. This is partially reflecting mirror from which we are taking the laser light. Here we are having a discharge tube having a gas of CO2 gas, nitrogen gas and helium in the ratio 1:2:3. It is now here it is a high tension. The pumping is being done by the electrical voltage here and the resonant cavity are being given by the two mirrors and the laser light is being given from the partially reflecting mirrors. This is the construction of a CO2 laser. Here all the conditions are being satisfied here. Requisites is nothing but the medium in which the transitions are taking place. It is a CO2 oxygen, carbon dioxide molecule in which we are getting the transitions, and here electrical pumping is done by the high tension voltage and the cavities here fully reflecting mirror and the partially reflecting mirror. This is a construction of a this is a construction of a CO2 laser and the tube is water cooled because a lot of heat is being generated because of the light. Next we go with the working of a CO2 laser. Now what is happening the moment you can see the energy level diagram over here. The moment the pumping is being given here, the discharge tube consists of a carbon dioxide, nitrogen and helium atoms. So here when the pumping is being done, first nitrogen atoms from the ground state reaches to the metastable state of a nitrogen atom here. This is here it is nitrogen atom which is a ground state and this is a metastable state. Due to excitation by the electrical discharge, the nitrogen atoms from the ground state reaches to a metastable state. Now the atoms in the metastable state collide with the carbon dioxide atoms which are lying in the ground state of CO2 molecule. The atoms in the metastable state of nitrogen collides with the atoms in the ground state of CO2 molecule and the ground state CO2 atoms are brought to the E5 state of CO2 molecule. Here it is energy is transferred by the collision. Energy that what is being collided? The atoms of nitrogen which are in the metastable state collides with the atoms in the atoms of CO2 molecule in the ground state. So energy transfer by collision takes place because of matching of energy levels. Ground state atoms of CO2 molecule reaches to the metastable state of a CO2 molecule which is nothing but a E5 state. Here E5 state of carbon dioxide molecule is in the same level as that of a metastable state of a nitrogen atom. See here you can see that the energy levels are the same. Due to matching of energy levels, resonant energy transfer takes place. So ground state CO2 atoms are brought to the metastable E5 level of a metastable state of a CO2 molecule. Remember, E5 state of a CO2 molecule is a metastable state. Now for our laser transitions, we need metastable states to achieve the population inversion. Now here, the moment number of atoms keep on increasing in the E5 state of CO2 molecule, population inversion has been achieved. So once the population inversion has been achieved, the transition from the E5 state to E4 state and the transition state from E5 to E3 states lead to the spontaneous emission, stimulated emission. Remember, stimulated emissions only occur when the transitions from the metastable state to the lower energy state. Here, since E5 state is a metastable state, the transitions from E5 to E4 leads to 10.5 micrometers and transitions from E5 to E3 leads to the 9.6 micrometers. So these two transitions are stimulated emission transitions. Now what is happening here? The moment the atom comes down to E4 state and E3 state by stimulated emissions, E2 level get accumulated. Here E2 level is getting accumulated with atoms from the E3 level as well as a E4 level. So here what is happening here? The helium gas which is sitting over here, the moment the atoms are increasing here in the E2 state, helium atoms collide with this energy atoms in the E2 level and brings that atoms of CO2 molecule to come down here. That means here helium gas is acting like a security, and the moment atoms comes, the number of atoms keeps on increasing here, helium gas will go and push these atoms to come down to the ground state, due to which the population inversion, the number of atoms in the E2 level will be reduced. Otherwise the population inversion, population inversion, the N5 state E5 state N5 should be greater than N3 and N4. But here if more and more atoms are getting accumulated, population inversion may be affected. So the number of atoms, the moment the atoms comes and sits here, the helium atom collides with this and make these atoms to come down to the ground state energy. So this is the working of a CO2 laser. This is the energy level diagram and the working has been explained here. The transitions from E3 to E2, you can see here the transitions from E3 to E2 and E4 to E2 and E2 to E1 are inelastic collisions. Now CO2 molecule in the E2 level undergo collision with the helium and H2O water vapor molecules effectively and come down to the ground state. So CO2 laser is a high power laser producing with few kilowatts in continuous mode. Thank you.